Hello, today I get to show you something really cool you can do with machine learning. And in this case, what's great about it is how easy it is to do. So what we're going to do is we're going to teach machines how to see, how to recognize objects so we can classify pictures. And in our use case, we're going to take two sets of images, houses with swimming pools and houses without swimming pools. And what I'm going to show you is how we can feed these images into a Jupyter notebook and run them through TensorFlow. And what we'll do first is we'll run them with the original model that has no idea whether there's a swimming pool or not in these pictures. But after we train the data set with our example images, it's going to do a pretty good job of recognizing which ones do and don't have swimming pools. Now, if you think about it, it's really easy for a person to look at these pictures, and even if you never saw a swimming pool before, if you saw enough pictures in one group or the other, you would pretty soon figure out that this thing is what distinguishes the two sets of data. But how a machine does that with a binary file and a bunch of ones and zeros is a much bigger problem. Fortunately for us, it won't be that big of a problem because we're going to take a lot of work that's already been done. It's already solved that problem by layers and layers of recognizing patterns and defining features and building that up until it can recognize, in this case, the Inception model was built to recognize 1,000 classes of objects. So it can recognize animals and different things. But it turns out it can't recognize a swimming pool. So what we're going to do is we're going to take the Inception model and we're just going to retrain that last part of it with our example images and see how it does. And it does pretty well, and it's really easy to do. So we're going to do this by using a Jupyter notebook, and you'll need a place to run the Jupyter notebook, and you'll want some computing power. The example I have is we've cached a lot of the information, and it's not a very huge problem, so we can run this example pretty quickly, which is great for demonstration purposes. But if you had a real problem to solve and you had 1,000 images, you're going to want some computing power to run that on. So what we're doing is we're using this IBM PowerAI systems via this Nimbix platform. And what you can do is you can run the example right there. If you go to github.com/IBM/PowerAI transfer learning, you'll see our repository has a README that walks you through the steps. So the first steps here will get you a trial account, show you how to fire up PowerAI notebooks, show you how to load up our example notebook and run it. And when you follow these steps, not only will you have a notebook platform and an ability to dial up however much CPU and GPU power you want, but you'll also have TensorFlow pre-installed because there's an option for that. Now, I don't want to walk through all that, so I'm going to jump ahead here. Once you follow the instructions, and by the way, we just go to a terminal window and we do a git clone of this whole Git repository as a convenient way to pull down the example data, which is our two sets of images, the Imagery training library that we got from TensorFlow that we're going to call from a Jupyter notebook, and the notebook itself is right here in Notebooks. So if you go in here and you click on the notebook, it will open it up, and I already have one running right here in this tab. But I want to say, if you're new to Jupyter Notebooks, it's a really neat environment to work in, especially if you're a Python programmer. But what's interesting about it is it mixes nicely formatted markdown text so you can explain the problem, and you see the formatting, but also you can include images to explain the problem and show pictures. And then it has cells that contain Python code, and as you run them, you'll see the output from each one. So it's a great iterative development process in that way, where you can kind of state your problem, show your work, see the results, and state your conclusion. Now, if I go back up to the top and walk you through this notebook, you'll see, as I said, the problem is explained at the top. And one of the things that I wanted to show you here is just kind of a picture of what we're doing. If you see this image here, the Inception model is pretty complicated. There are a lot of parts to it, and if you think about it, as I said, it needs to look at all these ones and zeros in a file and start to see patterns that become features and become objects. And that's a pretty big problem space. I'm glad we don't have to tackle it. It not only would take a lot of expertise, but a lot of time to do that processing and run all those layers. But what we're going to do is we're going to leverage all that work and come up here at the very end and retrain just this last part that says, okay, now that you've seen the images and you've identified objects in it, we're just going to classify whether it is a house with a pool or a house without a pool. And we do that by generating files at this little bit at the end here called Bottleneck Files. So we're going to feed our images in. We're going to train this classification part at the end, and we'll end up with something that has the recognition that we're looking for. So one of the things we do first, and the code is right here in the notebook, is we resize the images so we can drop various sized images in our folder, but ultimately we want them to be 299 by 299 for TensorFlow. So we'll do that right here in Python code. And in order for that code to work, we had to install this Python resize image module. And one thing to watch out for here is when you run it the first time, it will install this module, but it will probably fail on the import. So generally what you do is you can do a run all the first time. Usually I use cell run all. It'll fail on the import, but you just do a restart and run all, because after the installs happen with pip install, you usually have to start your kernel over again. So when you do the restart run all, it should run all the steps. And going down here, so it imports the modules, which are primarily standard Python plus some image processing and TensorFlow. And TensorFlow was already there because we picked that PowerAI TensorFlow application. The other thing that we're going to import, and this is the Imagery training library. I showed you we have it included in our Git repository, and we're just importing that using a relative path because it's relative to where we stored our notebook and where we're running. The parameters here control the input and the training settings. So when you run it the first time, you can leave them alone. But if you're going to fork it and tweak it and do your own thing, you might have different directories. That's defined here, so you can just refer to your original directory. You might also decide to tweak some of the training to see how you can affect the results with, say, a larger testing percentage, larger validation, or very likely just more training steps. Just loop through it and see how it works. The way we got this code in this Python library to work from a notebook is by kind of priming it by creating this flags object, and I'm setting the flags object right in that retrain module. So instead of calling it through the command line and passing in parameters, we're kind of tricking it by doing it this way, and that allows us to call it directly from the notebook. The model itself is downloaded, and this is again, it's in that module, and it will download it if it's not there. So the nice thing is it downloads it once, and then if you can run this over and over again, it shouldn't have to download it each time. It'll still be there. So for preparing the images, here's the code that I provided to do the resize. It's pretty straightforward. It will just resize them and drop them in a directory. And it's set up so that if they're already resized and they're already sitting there, you don't have to do that work over and over again. Here's just another example of visualizing. By the way, this is a picture that's a little hard to categorize, because if you've never seen a swimming pool before, you might have difficulty recognizing the difference between, say, a pond and a pool. And this is, other than the color, a little hard to recognize. Now, the other thing we provided is bottleneck files. And as this notebook runs, it's going to take the images and resize them, and it will create bottleneck files for them as needed. And that part's a fairly slow process. So what we did is we've already done this by experimenting in the past, and we just decided to store our bottleneck files. We include them in our repository, and we just use those cache bottleneck files instead of always doing the calculation over and over again. And one thing that I did here that's kind of tricky to make it work with this library as is I went through and I sort of backfilled every place where I had a bottleneck. I'm creating a placeholder image. So, and the reason I did that is because the code that we're going to see in a minute will take the list of image files and split them up into training, validation, and testing sets of images. And since the bottleneck files weren't there and the images weren't there, those were not being included in the test set. So all I needed was a placeholder that says drop an image there and it will use my cache bottleneck later on. That's how we kind of tricked it so the library would work as is. If you're going to pull the code in or contribute to it in TensorFlow, you might want to make that smarter. That's kind of a tricky way of doing it. Okay, but here's the main function, and you'll see what I was talking about here in a minute. Right here is the image list part. Okay, so first we come in here in the main, we're creating this inception graph, and we're going to create image lists, and you see it's going to decide the testing percentage, validation percentage. So we're taking random files out of our set of images, deciding which ones to train on, which ones to validate our training with, and ultimately which ones to test our results with. So we've tricked it to see bottleneck files as well as images, and that builds up this image list. Now we're going to go through and we'll cache the bottleneck files to be used in our training where they didn't already exist. We're going to tweak the model so that it understands that we have this final training operation. We're going to evaluate it. And then right down here, hold on, it's before the training, there it is, this part. Before we do the training, we're going to save the original graph. So we're writing out to this file, output graph orig. It's a variable, but you'll see the file later. So this is the Inception model with the idea that it would like to recognize houses with pools and without pools, but it hasn't been trained yet. So we'll see how that works. Now we're going through this big loop of training steps. We configured how many steps. It'll go through and it'll do training. And then we'll save the model again to see how we did as far in our training. Now as this runs, you'll see some output. It creates the bottleneck files as needed. It'll do some resizing where needed. You'll notice it skips a lot of these because we already cached them. But here's what the training looks like. And you see as it starts out, a little better than 50%. It continues to run through. These are 10 steps at a time. 85%, 90%, 92%. It keeps getting smarter and smarter as you loop through it. And ultimately, I think it's going to stop up here in the 90s. Sorry about the scrolling. So ultimately, it got to a train accuracy of 97%. That's really impressive. But the validation was 83%. And then when we finished, we ran it through a test again, and its accuracy was 86.5%. And what we're finding, it will vary depending on the random sampling. We're getting around 85% correct classification based on our image set. And keep in mind that it depends how good your image set is. It will depend on things like we included a picture with a pond or with a lake or things that had some objects that obviously confused the computers a little bit about whether it was a pool or just a bluish square thing. So you can tweak all that in your training. But if you want to make it be able to recognize those pictures and classify those correctly, you'll need more training, more images, better images, but it will learn. So we ran it through and we did our learning. So now let's see how we did. So right here in the notebook, we saved 4 images we did not include in the set. So these are ones that did not accidentally get trained on. Here are a couple of nice houses with pools, pretty obvious. Here are a couple of houses without pools. That one, it's a nice house, no pool. This one obviously has no pool. And this last bit here, so I'm just going to loop through. I'm going to take the original graph and run with that first. and then I'm going to run with the new graph that we built after the training. So before and after training. And I'm going to go through those 4 pictures that you saw up there. And we'll just run this Python code right here called label image. We're passing in the image in the graph. And you'll see the results. Before training, 50, 49, 50, 49, 50, 49. It's not much better than a coin flip as far as recognizing whether it has a pool or does not have a pool. After the training, these were kind of obvious, but 99% confidence it has a pool, 88% confidence it has a pool, 93% confidence it does not have a pool, and this one was only 68. Well, I'm surprised that one's only 68 without a pool. But oh, I see the weathered one was more confident than the other one. But anyway, this is kind of a great way to see that it worked. And the other thing is this little before-after test. You can grab these models. You might want to download them. You can run this against whatever images you bring in, whether it's in the notebook or on a command line, and do your own testing and see if you trained it to recognize well enough for your use case. It depends what kind of problem you're trying to solve, but ultimately what we did is we taught the machine how to recognize houses with or without swimming pools where it had no idea before what a swimming pool was. So I hope you found this as interesting as I did. We leveraged a lot of work and we solved a pretty interesting problem, just image recognition with machine learning. So thank you, and I hope you tune in again next time.